is your part 1 video for 6-1, Key Features of Exponential Functions. There is an activity in your book and in your student companion. We are actually not going to be doing that, or not going over that in this video, but that goes over some of the introductions for exponentials. So our question for this section, how do graphs and equations reveal key features of exponential growth and decay functions? So first, you need to know what an exponential function is. And an exponential function is any function of the form y equals a times b to the x power, where a and b are constants. A can't be 0, and b has to be something positive, and it cannot be 1. If b was 1, 1 to any power is 1. So that is actually going to be a linear function. That is not an exponential function. So we have part A here for example 1. What are the key features of each function? Include domain, range, intercepts, asymptotes, and end behavior. So we have f of x equals 2 to the x power, and I'm actually just going to sketch a quick table here to go through and look at some of these values. So 0 is always a good one to start with. If we plug 0 in here, 2 to the 0 power is equal to 1. If I plug in 1, I'm going to get 2. If I plug in 2, I am going to get 2 to the second power is 4. If I were to plug in 3, I'm going to get 8. 4 is going to give me 16, and that's actually going to be off of the graph. I want to consider negatives as well. This, which we'll look at the domain here in a little bit, but the domain is actually all real numbers because there is no x value that you can't plug into this equation. So if I plug in -1, 2 to the -1 power, remember negative exponents mean reciprocal, so that's going to be 1 over 2, so 1/2 or 0.5. If I plug in -2, 2 to the -2 power is 1 over 4, so that's 1/4 or 0.25, so that one's 0.5. And then if I would plug in -3, I'm going to get 1 over 2 to the third, so 1 over 8. So that's going to be, I think, 0.17 if you round. It's actually 0.1625. So every time you do this, it's going to keep getting smaller and smaller and smaller. It's not possible for this exponential to equal a negative number. It's going to get very, very small, and it's going to be approaching 0, but it's never actually going to cross that 0 line into the negatives. So -2, we said was going to give us a fourth, so that's about right there. -1 is 1/2, 0 is 1, 1 is 2, 2 is 4, and 3 is 8. So this is going to look something like this. And you can check this on Desmos, you can check this on the graphing calculator to check out to make sure that this is actually what it's supposed to be. So my domain here is all real numbers, -infinity to infinity. My range, the lowest y value we go down to is approaching 0. Now it never actually equals 0, so that's why I need a parenthesis there instead of a bracket. And then it's going to go up to infinity. We need to name the intercepts. This one does not have an x-intercept, but it does have a y-intercept, and that y-intercept is 1. That's what you get when you plug in 0. So x-intercepts, there are none. It does have an asymptote of y equals 0. That's actually going to be the x-axis where we're approaching that or we're never going to cross. And then we have end behavior. So as the function moves to, let me rewrite that. I don't want to write that way. So our end behavior, as x is moving to the left, so as x approaches -infinity, f of x is approaching 0. So your line is approaching the y value of 0 on, this is for the left. As x approaches +infinity, f of x is approaching +infinity, and that is for the right. So the left side is going to 0, the right side is going to infinity. Now we can adjust exponentials. We can multiply by different things. We can add and subtract things from them to change the different values that we have. So we have this one, 5 times 1/2 to the x power. And if I look at my table for this one, I'm going to call that y instead of g of x, but you get the same thing both ways. Again, starting with 0, that's going to give me 5. 1/2 to the 0 power is 1, times 5 is 5. If I plug in 1, 1/2 to the first power is 1/2, times 5 is 5/2, or 2.5. If I plug in 2, 1/2 to the second power is 1/4, because I'm squaring top and bottom. 5 times a fourth is 5/4, which is 1.25. If I were to plug in, say 3, 1/2 to the third power, that's going to be 1/8. 1/8 times 5 is 5/8, and that is going to be 0.675, if I've done my math correctly on that. Just check that. 0.625, not 75. That sounds a little bit better. And if you plug in 4, 5, and 6, and 7, you'll see that that number gets smaller and smaller and smaller. Now, if we go the other way, if we plug in -1, 1/2 to the -1 power, that's going to flip your fraction and turn that into a 2. So you get 5 times 2, which is 10. If I plug in -2, 1/2 to the -2nd power, that flips it again. So you end up with 4, and then 4 times 5 is 20. So that's going to keep getting bigger and bigger. So I can't graph -220. -1 is going to be up here at 10. 0 is going to be at 5. 1 is at 2.5. 2 is at 1.25. 3 is at 0.625. And you would see, if you actually look at the graph of this, that it is going to be getting closer and closer and closer to 0 as we go down. It, again, is not able to actually reach 0 or into any of the negatives, but it is approaching that. Our domain for this is the same. It's -infinity to infinity. And actually, with all exponentials, the domain is -infinity to +infinity. Your range, however, is still 0 to infinity, because you're looking at bottom to top. And even though the bottom occurs on the right of the graph instead of on the left of the graph, like the previous question, the range is still 0 to infinity. Your y-intercept is 5 in this case. This one also does not have an x-intercept. Now, it is possible for your graph to have an x-intercept. If we were to take this whole graph and shift it down any number of units, you would most likely cross through the x-axis at some point. So it's not impossible for exponentials to have a y or an x-intercept. It's just not always a given. There is always going to be one y-intercept, but x-intercepts, well, they might not happen. And this one has the same asymptote as the previous one, y equals 0. To change that asymptote, you actually have to have something added after the exponential, like a +3 or -5, and that number that's added after is actually going to be your horizontal asymptote. There's not ever going to be a vertical asymptote with exponentials. Whenever we talk about logarithms, which logarithms are the inverses of exponentials, they're going to be reversed. So with an exponential, the domain is all real numbers. With a logarithm, the range is all real numbers. So it's like you're swapping them. Remember, inverses, we swap the x and the y, the domain and range swaps. So with an exponential, there's going to be a y-intercept. With a logarithm, there's going to be an x-intercept. So it always goes opposite of what we have. As far as your end behavior goes, as x goes to the left, that's your -infinity. My arrow is going up, so that's approaching +infinity. So that's my left. For the right, as x is going to the right, that is where your graph is approaching 0. So that's your right movement. we're going to take a look at some changes, and you'll see how your asymptotes are going to change with these. So we're looking at some transformations here. So each one we're using 3 to the x as our starting parent function. And I'm actually going to go through and graph that first. So if we look at the parent 3 to the x, of course, if I plug in a 0, I'm going to get back 1. If I plug in a 1, I'm going to get back 3. If I plug in a 2, I'm going to get back 9. So that's like way up here. 1 or negative 1 is going to give me a third and then a ninth. So it's going to look something like this. So it's not actually going to cross the x-axis, but it's going to look similar. Now, if I take that same thing and I multiply by a negative, I'm going to have all the same x values, but the y values are going to be opposite. So this is going to be down at negative 1. That's at negative 2. That's down here at negative 9. That's negative 1/3, negative 1/9. So everything is going to look like this. And it says, how do the asymptote and the intercepts compare? So the asymptote is going to be the same. And the intercepts, again, that would be the y-intercept, is going to be opposite. So the black parent function had a y-intercept of 1. The new function has a y-intercept of negative 1. So I have the same starting function over here at b. I'm going to go ahead and graph that. So there's my function. And this one has a -4, so I'm going to be taking that graph and moving all the y values down 4. So 1, 2, 3, 4. The 1 moves down to negative 3. 1, 2, 3, 4. The 3 moves down to negative 1. My, what did I say that was? My 9 is going to move down 4, so it's going to be at 5. My 1/3, if I keep my spacing 1, 2, 3, 4, that's going to be negative 3 2/3, so I'm going to be looking at something like that. So my asymptote has now moved down 4, and my intercept has also moved down 4. So anything having to do with the y values, those have all moved down 4. You're basically just looking at how your function is going to change whenever you're going through that. So that's where I'm going to stop this first video. So that deals with all of our graphing information. Our second video is going to be looking at some of the equations and seeing how our exponential functions interact with each other.